Hello, my name is Pamela Cuther, and I am an instructional specialist for secondary mathematics with Richmond Public Schools. Welcome to the Richmond Public Schools Distance Learning Modules. In this series, we will learn Algebra 1, where we will have a different focus each week. This week's focus is SOL A.4a, Evaluating Expressions. Today we will review term, like terms, and combining like terms. Before we get started, you will need a few supplies: your interactive notebook or a few sheets of paper, pencil or other writing utensil, and you will need the Desmos calculator. Before we learn our skill for today, we need to familiarize ourselves with a few vocabulary terms. Please copy the vocabulary term, illustrations, and definitions into your notebook. There is a definition link next to one of the terms. Please click on that to get the definition. We will pause to give you time to copy that information. Now we are ready to look at our instructional videos. There are 3, which will explain our skill for today. Before we start, please open the notes. Copy the notes and fill in the blanks for each of the videos. The videos are also linked in the presentation. After you're done watching the videos and completing the notes, please come back to this presentation. Now that you've learned our skills for today, we will look at some model examples. Please copy and complete the examples in your notebook. Feel free to copy down any additional information or helpful hints that you hear throughout the explanation. Our first example is negative 6k plus 7k. Remember, when we have terms that are alike, and these are alike because they have the same variable raised to the same exponent, that's one of your definitions, we only need to combine the coefficients. The coefficients are the numbers that are in front of the variable. So here we have negative 6k plus 7k. They are alike, so all I need to do is combine the coefficients. So I have negative 6 plus 7, which gives me 1k. Now remember that the 1 is understood to be in front of the variable, so normally when we write that answer, we would not write the 1, but we know that it's there. So the better answer, the more algebraic answer, would be just to write k. Let's look at the next example. N minus 10 plus 9n minus 3. So if you notice, I use my markers and some shapes to identify my like terms. I strongly suggest doing that. Even if you don't have markers, you can simply draw the boxes or the circles. Sometimes if you have 3, you might draw a triangle. Or you might draw a wavy line under there, but you need to draw some type of symbol to indicate which terms are alike. That'll help you stay grounded on which ones you want to combine. So here I have n, and then I have plus 9n. So that essentially means that I'm going to be adding 1n, because remember the 1 is understood to be there, plus 9n, which is going to give me 10n. I'm going to bring that into my final answer. Then I have negative 10. Now notice I said that is negative 10 because I read it first. I wouldn't say minus 10. I have to read it as negative 10. So that's going to give me negative 10 minus 3. Those are my constants. Remember, constants are terms that have no variables. So I have negative 10 minus 3, which gives me negative 13. So then when I want to bring those back together for one final answer, my final answer is going to be 10n minus 13. Remember, when you write your final answer, when you combine your like terms, the constants always go last. Let's look at a couple problems for you to try on your own. Remember to identify your like terms first, and then you're going to combine the coefficients. Make sure you pay close attention to the symbols in front of those terms. Give you a couple more seconds. All right, let's look at the solutions to these problems. Make sure you make any corrections to your work. If you need to had any errors and you need to make any corrections, please make those when we see the solutions. So here are the solutions. Let's go over those very quickly. So we have 4p plus 2p. Remember, those are alike because you have the same variable raised to the same exponent. So all you have to do is add the coefficients. So 4 plus 2 is 6. So you have 6p. The next one is n plus 4 minus 9 minus 5n. So again, I use my boxes and my circles. You can use colors if you like. Either way is fine. But I have n minus 5n, which again we said a variable without a number in front of it is understood to have a 1 there. So there are all variables have coefficients. If you don't see a number, it's a 1. So we have 1n minus 5n, which gives us negative 4n. Then I have 4. Notice I read that as 4 because it has a plus in front of it, so it's positive. So that's 4 minus 9, which is going to give us negative 5. So when I want to write that as a final answer, I have negative 4n minus 5. Remember, your constants go last, and you have to hold on to those signs. These answers look a little weird because we're used to getting just numerical answers, but here we're simplifying. We're not solving, we're simplifying. So we're going to get it into the simplest terms, and sometimes that means it's not nice and neat as a whole number or integer number. The next one is negative 5 plus 9n plus 6. So if you notice here, the only things I can combine are the negative 5 and the 6. The 9n doesn't have any other n terms to go with it. So I have negative 5 plus 6, which is going to give me 1. And the 9n, I just bring that down because I don't have anything else to go with it. But when I reorder my answer, remember the constant goes last, and so I have to rewrite that as 9n plus 1. And that concludes our lesson for today. During your remaining work time, please complete the practice problems and the online practice. The answers to the practice problems will be in tomorrow's module. Please enjoy the rest of your day and stay safe.